Alright guys, so in this video we're diving into 1.2 for our pre-calculus talk, which we talk about linear equations in two variables. So we're going to open up the conversation once again with some review material, thinking about what we mean by two variables. Well, usually that's shown in linear forms kind of like this, and we know it as slope-intercept form, or y equals mx plus b. Alright, so my next question to you then is, well, what if we're going to be not looking at two different variables? How do we identify the particular areas, I guess, of what happens when we're dealing with maybe non-two variables? What types of lines are actually formed? And as we kind of looked on into these a little bit, we started dealing with our talk in 1.1. So the first kind of opening question we got to talk about here is, what type of line is formed with x equals a, some random constant a, right? So x equals a. Well, hopefully we understand that when x equals something, that's going to give us a vertical line. All right? And then, well, what about the slope of a vertical line? Well, we know the slope kind of in a sense, and we're going to talk more about this in a sec, as rise over run, right? Well, if I'm dealing with let's make a quick little makeshift graph right here. So let's say this is the value of x equals a. Well, what's my rise? Well, my rise goes on up, on into infinity. What's my run? It goes nowhere, right? So it goes nowhere. So how are we going to have anything divided by 0? And so obviously that becomes an issue in an example like this. That's why we have an undefined slope that we are dealing with. Well, what about when it's y equals c? Y equals some constant value. Well, hopefully we know that that is a horizontal line that we are dealing with. So once again, I'm kind of taking a look option here. So we'll call this y equals c right in here. So then the question is, well, what about the rise over run? Well, kind of the rise, not going anywhere. So there's a 0 over going on and on and on and on and on and on and on to infinity, all right, or the opposite way to negative infinity. But regardless of what that value is on the denominator, the value of 0 divided by anything has a slope of 0. And that's going to lead us into the main goals of this lesson. So how do we find the slopes of lines? How do we write linear equations in two variables? Looking at some slopes with parallel and perpendicular lines as a refresher on memory, and then some more real-world application problems as well too. So that's going to dive off into the first thing actually, is we're going to start looking at a real-life example to kind of show a little bit more so what we're dealing with. So the first question that we're dealing with is using slope as a ratio, not a ration, a ratio. So it says the maximum recommended slope of a wheelchair ramp is 1 over 12. A business is installing a wheelchair ramp that rises 22 inches over a horizontal length of 24 feet. The question is the ramp steeper than recommended in this particular case? All right, well, as you can kind of see, we have a little diagram that represents exactly what we're showing in this example. And once again, the question is this ramp going to be steeper than recommended? Well, let's think about exactly what we're dealing with. This is all technically dealing with our inches. So let's convert these feet first and foremost to inches by multiplying it by 12 and getting 288 inches first and foremost. So just kind of be on the lookout for something like that where they kind of try to trick you a little bit. Now we might be able to deal with. And so this is kind of our opening statement that, the slope itself is a definition of steepness, right? How steep is something? How intense is the incline or decline of a particular, in this case, a ramp, or what we're going to talk about more so as a function? How steep is the slope of that function? Well, let's think about the rise over run in this case. We know that the slope is the vertical change over the horizontal change, right? That's what it means to be the rise over run, the horizontal change dividing into our vertical change. And so, well, what's the vertical change? Well, we start from nothing, we go up 22 inches. What's our horizontal change? Well, we start from nothing and we go 288 inches here. All right, well, if this is our vertical change over our horizontal change, by definition, that's what the slope is. So this is roughly going to give us a value, in this case, of 0.076. So the question is the ramp steeper than recommended? Well, let's take a look. What does 1/12 actually equal? Well, 1/12 gives us roughly a value of 0.083. And so let's think about it. Obviously, our current slope is 0.076. Our recommended slope is 0.083. So the slope of the ramp is not steeper than recommended. So it would check off, and it would be good to go for an example like this. All right, and now that's going to lead us into what I want to really start getting us into when we talk about slope. Now, it's very elementary to say rise over run. All right, in my opinion, it's very elementary to even go by the definition of y2 minus y1 over x2 minus x1. What I want us to start thinking of slope as is the change in y over the change in x. Super, super, super important, in my personal opinion, as you dive into higher level mathematics, is to get away from rise over run and all the kind of elementary things that we've talked about so many times in the past, is because we are going to be so diving into changes in y's versus changes in x. And that's what this little triangle stands for. It stands for delta. Delta is that Greek alphabet letter for Greek symbol, I should say. That triangle, and it stands for the change in. All right, it stands for change. So start getting your mindset to understand that slope is a change in something. In this case, change in y over the change in x. Well, one of the other parts of this video is to dive on into writing equations in two variables. And now this hopefully is a reminder for you from Algebra 2 and Algebra 1 even of point slope form. I always told my Algebra 1 kids that point slope has a simple name. You use point slope when you're given 1 point and the slope, right? Pretty basic as to when to use point slope form. And you can obviously use it in multiple different ways. But when you can be given at least 1 point and be at least even able to find that slope, boom, you can easily use point slope form. So we want to write this equation in point slope form. So it says find the slope intercept form of the equation that has a slope of 3 and passes through the point 1, negative 2. Well, we would quantify this as x1 and this as y1, not y2. All right. X1 and Y1 here. So let's take a look. We know we want it in the end as Y equals mx plus b. That's what the goal is. But my personal take is I like putting things into point slope form first, and then we can quickly make a change to Y equals mx plus b or slope intercept. So Y minus Y1, which in this case was a negative 2, is equal to the slope, which had a value of 3 in this example, times x minus x1, which had a value of 1. Well, y minus a negative 2 is y plus 2. 3 times x is 3x. 3 times negative 1 is a negative 3. I'm going to subtract that 2 on over, and we get 3x minus 5. Boom, there is our slope intercept form. So again, hopefully that is more of an refresher more than anything else. So what I would like you guys to do me a favor is try this one here on your own. Find the equation of the line in slope intercept form of the line that passes through the following points. Give it a shot, and we're on to the next one.